Hi Year 11, so we've done differentiation the hard way using first principles. Now we're going to do it the easy way. Differentiation is just the process of taking the derivative of a function. Remember that when you use first principles, you find a function that when you substitute in a specific point, you are given the value of the slope of the tangent at that point. So really important specific thing here, you're not finding the equation of the tangent. You're finding the value of the slope of the tangent. And that makes sense, doesn't it? Because remember when we differentiated something like y equals x squared, you got the function y equals 2x. Now, if we drew that at this point, obviously the equation of that tangent isn't 2x. The equation of that tangent there isn't 2x. The equation of that tangent there isn't 2x. 2x is the equation of a very specific line. So this 2x is not the equation of the tangent. What it is something that when you substitute in a specific point, like x equals 2, it tells you the slope of the tangent at that point. All right, now that's going to be very important in a little bit. So we've been talking a lot about f of x, and we've been talking a lot about f dash of x. But remember we talked initially about how Leibniz was a fellow inventor, if you like, of calculus. He came up with the idea as well. And so there's two notations. We've got the f of x and f dash of x, but we've also got dy on dx. And what that means is, in general, if y is a function of x, so that's what f of x means, a function of x. If y is a function of x, then the derivative of y with respect to x is denoted as dy on dx. Now that is the same, which is equal to f dash of x. So we call that Leibniz notation. So if you get questions where you're asked to find dy on dx, remember that's actually the same as f dash of x. Now similarly, it doesn't have to be y and x. So if z is a function of t, for example, or if q is a function of c, it doesn't really matter what we use for y and x. If z is a function of t, then the derivative of z with respect to t would be denoted as dz, derivative of z with respect to t on the bottom. Okay. Now, if you remember some of the previous examples, and you might not, but just trust me on this, if you differentiate these functions from first principles, so f of x equals x, if you differentiated that from first principles, f dash of x would have been 1. If you differentiate f of x equals x squared, f dash of x would have been 2x. And if you differentiate f of x equals x cubed, f dash of x would have been 3x squared. So this suggests the following general result, which we call the simple power rule. If we have f of x equals x to the n, f dash of x equals n times x to the n take 1. We multiply down and we subtract 1, okay? As we go through this, I might say some rules. So here we multiply down, subtract 1. What that means is for any function that's in this format, where you've got a number raised to the power, the derivative of that will always be multiplying down, so multiplying the power down the front, to put the n out the front, and then taking 1 off that power. And that will give you the correct answer. It's really quick. You don't have to go through that whole laborious process. So if we think about now applications of that, if the function is a constant, so if it's c, we could write c as f of x equals cx to the 0. All right. So then if we multiply down, so we put that 0 out the front, we go 0 times cx to the 0, take 1. Now, of course, x to the 0 take 1 is negative 1, but we've got 0 times out the front, so that equals 0. So the derivative of a constant, f dash of x, is always equal to 0. Now we can do similar things for the rest. So if f of x equals mx plus c, well, we know the derivative of c is 0. X is really x to the 1, so f dash of x would be 1 times mx to the 1 take 1, which equals mx to the 0 which just equals m. Now we have something called the constant product rule. So if we've got a number out the front, so we've got just a number multiplied by a function, f dash of x would just equal k times g dash of x. So if the function is written as a multiple of another function, the derivative is the same multiple times by the derivative of that other function. Now if you're adding if your function is actually the sum of two smaller functions, f dash of x will just equal the derivative of both functions added together. So that's f of x equals g of x plus h of x. So f dash of x equals g dash of x plus h dash of x. And finally, if you've got a difference, same rule applies. F dash of x would just equal the difference between the two derivatives of those two functions. So that's our introduction. How does that actually work with some examples? All right, some examples. So let's remember our general rule is f of x equals x to the n, then f dash of x would equal n times x to the n take 1. Right, so if we've got f of x, n is obviously equal to 3, so you wouldn't have to write this, but just for now, n equals 3, so f dash of x is going to equal 3x to the 3 take 1, multiply down, subtract 1, which equals 3x squared. Now if we've got a number out the front, remember we're going to find the derivative and multiply it by that number. So we're going to go f dash of x is actually going to equal, we're going to leave that number out the front 5 times, then multiply down 2x and then take 1, 2 take 1. So it's going to be 10x to the 2 take 1, which is 10x to the 1, which is just 10x. If we've got a function with it which is actually the sum of a whole lot of different functions, all we have to do is find the derivative of all those different functions. So the derivative of this, f dash of x, is going to equal, well, we leave that number out the front, 4 times multiply down, let's just differentiate this bit, multiply down, subtract 1, plus 6 times x, now I should have multiplied down, shouldn't I? So 6 times 2 to the x outside of 2 take 1, multiply down, subtract 1, plus 12. Now just remember 12x is really 12 times x to the 1, so if we multiply down, we're just multiplying by 1, so we don't really need to worry about that. Multiply down and then subtract 1, so 1 take 1, plus, and then 1 is a constant, and we learnt that the derivative of all constants is 0, so it's going to be 0 on the end. So if we simplify that, that would be 12x squared plus 12x plus 12x to the 0, which is just 12. Alright, so that's the derivative of that function. Now, this one down here, remember, rule number 1, I'm going to write here, write all parts of the function. So write all parts of the function without fractions. That's going to really help in this situation if you get rid of the fractions first. So really important here, I'm not going to differentiate yet, so I'm just going to write this as f of x, okay, equals 3x cubed. Don't write f dash of x because you're not differentiating, you're just writing it in a different format. 3x cubed plus 2x, take 3 over x, so that's 3x to the negative 1 plus 5x to the negative 3. Alright, so I've done f of x, I've just written it in a different format. Then I'm going to write f dash of x. I'm going to leave the constant out the front, multiply it by, multiply down, subtract 1. Okay, plus 2x, now x is x to the 1, so I'm multiplying down by 1, so I'm not going to worry about it. X to the 1 take 1, plus, take 3, be careful here, times, multiply down, negative 1, x to the negative 1 take 1, multiply down, subtract 1. Finally, plus 5 times, then multiply down, negative 3x to the negative 3 take 1. Alright, so f dash of x then is going to be 9x, 3 take 1 is 2, so 9x squared, plus 2x to the 0, take, now negative 3 times negative 1 is just going to be positive 3. So x to the negative 2. And then 5 times negative 3 is going to be negative 15. Take 15, x to the negative 4. Alright, so that's going to equal 9x squared plus, now x to the 0 is just 1. So 9x squared plus 2 plus 3. Now you could write it as 3 over x squared, or you could leave it. It's fine if you left it as a negative power unless it specifically asks you to. Take 15 over x to the 4. And you've differentiated that one. Alright. Now here, we had one rule up here, write all parts of the functions without fractions. Down here, we also want to write all parts without thirds. Okay, so this is where the previous topic is going to come in really handy. So we're going to write all parts without thirds. And to do that, we're just going to, again, we've got y here. So if we've got y, we're just going to write it as y equals 3x squared, take 5x to the half. Again, I'm not differentiating anything, I'm just rewriting the function. Now that I differentiate and I'm differentiating y, I'm going to write it as dy on dx because I'm differentiating y with respect to x. Multiply out the front, multiply down, subtract 1. Now you might be able to do it in less steps than this now, and that's perfectly fine. Multiply out the front, multiply down, subtract 1. Okay, so dy on dx will be 6x to the 1, which equals 6x. Take 5 on 2x to the negative a half. Because I did a half, take 1 up there. Alright, now x to the negative 1, that's going to equal the same thing as 6x, take 5 over 2 square root of x. But you wouldn't have to write it like that if you didn't want to. Remember, x to the negative half, that puts the negative, puts the x in the bottom, and the half makes it the square root. Alright, so the final one, a little bit tricky, looks a little bit tricky, but it's actually not that really. When you've got a bracket up the top like that, and you've got something, an exponent, the same base on the bottom, you want to, in this case, you want to, 1, expand the brackets, and then you want to use index laws to remove the base. Now you want to really make sure here that you're not breaking any rules of algebra. Alright? So, if we've got this function y equals 3x take 2 all squared, I'm just going to simplify first and make that 2y equals, let's expand. So this is perfect squares. We're going to use the formula a take b all squared equals a squared take 2ab plus b squared. So that is going to equal 3x squared. Remember, it's all squared, so it's going to be 3x all squared take 2 times 3x by 2. Okay, not by negative 2 because it's negative 2 times a times just b, which is the number after the negative sign, plus b squared, which is plus 2 squared. So that y all over, don't forget your denominator, all over the cube root of x. So y is going to equal 9x squared take 12x, because 2 times 3 is 6, 6 times 2 is 12, plus 4, over, now I'm going to use the index laws to remove the base, remembering first, of course, that I want to get rid of that third, so make that x to the third. Alright? So then we're going to remove our base. Now to do that, remember that y is actually the same as this. That is what this is. Don't just cancel that x with one of those terms. You have to, each of those terms is divided by x to the third. That's what that means. So before you do any index laws, make sure you split up your base like that. Alright? And then we're going to keep on. Notice I haven't differentiated anything yet. Now I'm going to simplify it. So I'm going to do 9x squared take a third, because I'm dividing means that I take 2x to the 1, take a third, plus 4 over x to the third. If I put that up the top, it's going to become x to the negative a third. All right? When I take that up the top, it becomes x to the negative a third. So y is going to equal 9x to take, that's 6 on 3, take 1 on 3, which is 5 on 3, 9x to the 5 on 3, take 12x to the 2 on 3, plus 4x to the negative a third. Now finally, I'm actually going to differentiate. So dy on dx then is going to equal, multiply down, subtract 1. So I'm going to do it in more steps now. I'm going to multiply down, and I'm going to get 9 5s are 45. So that's 45 on 3 times x to the 5 on 3, take 3 on 3 is 2 on 3. Multiply down 24 on 3, x to the 2 on 3, take 3 on 3 is negative a third. And then multiply down, I'm going to get negative 4 on 3 times x to the negative 4 on 3, because negative a third, take 3 on 3, take 1 is negative 4 on 3. Now, of course, I can write that without my negative powers. So that's 2 on 3, take 24 on 3 root x, but that's going to be a cube root. Take 4 on 3 x. Now you could just write that as 4 on 3 x to the 4 thirds. If you're going to do that, it probably makes sense over here to write this as 3x to the third. But again, you only need to do that if it says give your answer in positive powers. If it's not, this answer up here is perfectly right, and it's probably a good idea to leave it like that so you don't make a silly mistake. All right. So finally, how do we actually apply this? So find the slope of the tangent to this point. All right, if we've got slope of the tangent questions, we're going to follow some easy steps. You're going to find the derivative, all right, and then substitute in the point. And that will give you the slope of the tangent. Okay, remember, when we found the derivative at a specific point, that gave us the slope of the tangent at the point. It didn't give you the equation of the tangent, it gave you the slope of the tangent. So finding slopes of tangents, you just follow those steps. So let's go. Let's find the derivative of this function. But first, we are going to make sure that we have everything. We don't want any surds or any fractions, so let's get rid of them. Okay, y equals 3x squared plus 7 plus 2x to the negative 1. Right, now I've got it in that format. I can differentiate dy and dx, therefore it's going to equal multiply down, subtract 1, 6x to the negative 1, derivative of a constant, 6x to the 1, sorry, because 2 take 1 is 1. Derivative of a constant is 0, so the derivative of 7 is just 0. Then multiply down, so 2 times negative 1 is negative 2. 2x to the negative 2. Okay. Again, this is easier to work with as derivative 6x, take 2 over x squared. It's easier to work with now if you've got the x on the bottom. All right, now we want to find dy on dx where x equals 2. That's what that means, dy on dx where x equals 2, that notation we've got here. So that's going to equal 6 times 2, take 2 on 2 squared, which equals 12, take 2 on 4, which equals 11.5. Therefore, the slope of the tangent where x equals 2 is 11.5. Slope of the tangent where x equals 2 is 11.5. All right, and one more example. For f of x equals x to the 4, take 31x. First find f dash of x and f dash of 1. So we're finding the derivative, and then we're finding the derivative when x equals, the slope when x equals 1. Then, for y equals f of x, find the set of xy values such that f dash of x equals 1. What does that mean? That means to find the coordinates of the point where the gradient of the tangent is equal to 1. All right? F dash of 1 means we're finding the slope at the point 1. But this case, it wants you to also find the coordinates where the slope equals 1. All right, so let's do it systematically. F of x equals x to the 4 take 31x. We've got no fractions, no thirds, so we can go straight into differentiating. We're going to multiply down and subtract 1. 4x, 4 take 1 is 3. And then we're going to find the derivative of that. That's going to be multiplying down 1, so that's just going to leave us with 31. And then x to the 1 take 1 is x to the 0, which is just 1. So our answer is 4x cubed take 31. All right, f dash of 1, well, that's the slope of the function when x equals 1. That's going to be 4 times 1 cubed take 31. All I did was I replaced the x in that function by 1. And that tells me 4 take 31, which is just negative 27. So that implies, and just this is not answering question, but for your understanding, the slope of f of x equals x to the 4 take 31x at x equals 1 is negative 27. Alright, that's the instantaneous rate of change. That's the slope of, in fact, it's really the slope of the tangent to f of x at x equals 1. Alright? Then find the coordinates of the point where the gradient, or where the slope, or where the derivative is equal 1. Notice slope, gradient, derivative is equal to 1. That's all saying the same thing. So when does f dash of x equal 1? Well, when does 4x cubed take 31 equal 1? When 4x cubed equals 32, when x cubed equals 4, so equals 8, so therefore when x equals 2. So there's only one point, apparently, when that is the case, when x equals 2. And so then to find the coordinates of the point, we're just going to find the y value. So x equals 2 is the point on the curve, so its y value is f of x. We're going to now substitute x equals 2 into here. It's going to equal 2 to the 4 take 31 times 2, which equals 16 take 62. And 16 take 62 is 46. So therefore the coordinate of our point at that point is 2, 46. So what did we do? We found f of x. We then found f dash of x, which is the general equation that helps us to be able to find the slope of the tangent at any given point on this curve up here, Then we found f dash of 1, which was telling us the slope of the tangent to f of x when x equals 1. Then we found when the slope of the tangents to 4x cubed take 31, our original f of x, is equal to 1. And we found the coordinate of that point. And that's it for this section.